Every 2 minutes there is a domestic fire caused by a fire or an explosion. One in 4 of these fires is started by an electrical accident. This represents around 263,000 domestic fires. Fires are the cause of around 100 deaths and more than 10,000 injuries, 70% of which occur mainly at night. How to protect yourself and others from fires. What device should be installed in your building? How to install and maintain them. How to train your staff or family members. What arrangement should be put in place? Welcome to this training session, Fire Protection Part 1. We're going to ask you to subscribe, hit the notification bell, and share this video to raise awareness. Since most building fires are primarily electrical in origin, let's start there. Let's now look at some causes of fire and burns in electrical, domestic or industrial installations. We will mention 3 of them. Poor electrical contact, which can cause a fire. The undersizing of electrical installations as well. Finally, overloading an electrical line or circuit. The main cause of electrical fires is poor contact. A poor contact does not allow optimal passage of the current. As the current passes through the conductor contact, if this is poor, there will create heating of the metal parts of the contact. The electrical contact is an essential element of an electrical installation. Calling a qualified electrical technician is an obligation. It will be necessary to sufficiently tighten the screws of the protection devices and fuse. Do the same also for the switch and sensor control devices and secure the power supply conductors of the lamps and power sockets. Pay attention to the connections in the junction boxes, insulate the conductors well, use quick connectors or sugar connectors for this. Tighten the conductor wire tightly. In short, to avoid poor contact in junction boxes, protection devices, relays, control devices, switches, sensors and others, it will be necessary to tighten the screws sufficiently. Check by trying to pull with the pliers with the conductive wires.
It sound right, boy.
Here are other tips for improving electrical contacts made by welding electrical connections. That is to say, after forming the splice, add a layer of solder to strengthen the contact. Use of valve terminals, also called quick connector or WAGO. Use of connection caps. Use of terminal block, also called sugar connector. Use of crimped sleeve fittings. Use of a bolt, screw and nut. In short, to avoid poor contact in the protective device junction boxes, relay conditions in control devices, switches, sensors and others, it will be necessary to tighten the screws sufficiently. Check by trying to pull with the long nose pliers if the conductive wires hold. The second point is undersizing. We speak of the undersizing of an electrical installation when the power of the installation is greater in relation to the section of the electrical wires and cables which supply this installation. This can lead to overloading of the electrical installation and frequent breakdowns. Additionally, it can cause safety issues such as fire hazards. Each electrical installation must be correctly sized to guarantee reliable operation. As already said, you must call a qualified electrical technician. To determine the correct section of the power cables, you will need to determine the total power to be installed in single-phase or three-phase and deduct the value of the section required, taking into account the extension of the power. The installed power can increase over time when other devices are added to the installation. Here is how to calculate the power of a single-phase or three-phase installation. We will also take into account the length of the line. The longer the line, the greater the resistance will become and the heating will become greater. See the electrical laws of Pouillet and Joule, which will be the subject of study in our next videos. When choosing the section of the power cables, other elements must be taken into account such as the operating current, the nature of the conductors, in copper or aluminum, the nature of the PVC or PRC insulation, the core of the single-strand or multi-strand cable, and pause mode, buried or not buried. Regarding the choice of the section of the power cable, as a reminder, we will take into account the installed power in single-phase and three-phase, the length of the line, the total current, the nature of the core of the conductor, the nature of insulation, the number of conductors in the cable, and the type of installation. We can now use the table which indicates the appropriate section to use for the installation conductors, the main element and the intensity of the current that each circuit will consume. From this, we can calculate the section using the density formula or use a table to determine the sizing section of the installation. Knowing how to size also means knowing how to properly distribute the circuits of the installation. Here is an example. It is necessary to determine the different elements that will be in each circuit, for example, light, sockets, appliances, air conditioning, heating, and calculate the total power of each circuit, adding a small excess as we have already mentioned by this, as the power can expand after installation when adding other devices. Finally, knowing the power of each circuit, it will be necessary to determine the section of conductor to use following the method that we have already mentioned to ensure its protection. But as you notice here, at the head of each circuit there is a circuit breaker, and at the head of several combined circuits, a differential circuit breaker must be installed to protect people and equipment. A small detail: always distribute the circuits in a balanced way, not too many elements in one circuit, while the others have fewer. When laying out circuits, please use appropriate items such as crimpers, cable plugs, and crimping pliers. Be careful not to overload outlets or extension cords. Use good quality devices. Determine the power of a circuit before adding other devices.